Okay, so first let me set up what it is that we were trying to do here. So here, this is a typical CRM application, a project management software like Jira or Microsoft Teams. This is open source one called Redmine, and this already exists. We have implemented it for one of the clients. But as part of the AI part, which I was looking into, what we have done is we have added a agent here which understands natural language. Now, before this agent, you had to understand what all of these menus means. You have to go to overview, you can go to issues, and you can select projects, etc., which is fairly complicated. Now, get the project name from here, uh, or you can go here also. All this we want to sidestep, and we want to allow this digital assistant to take in natural language queries such as show me issues assigned to Abhishek, who is me, or it could be anybody else, like depending on who you want to see it. And now the idea is that based on this natural language, the AI system will figure out all the entities and the relationship between those entities and navigate you to perform those queries. This is what we had set ourselves up to do. The architecture of that is that at the time of the setup, the assistant has to be set up. This assistant has to be set up for each individual deployment. The IT admin has to go through all possible flows once and record them. For example, the IT admin may have recorded this flow, show me issues for Yuresh in this project called Digital Assistant. Now, obviously, at the time of recording, you can only set up one flow for one use case. You cannot set up recordings for show me issues for John, show me issues uh, for Mary, and all the hundreds of the names of the projects, which is where the LLM part kicks in. The LLM is supposed to match first, find the most relevant recording, and then patch in the names of the entities. So here, the most relevant recording which has been found is this: show me issues for Eurasian Digital Assistant. That's fine. When we play it, the LLM is supposed to, I mean, before the LLM kicks in, the existing front end flow, which written in React, will take us to all the steps. Like here, it's selecting the name of the project, then it's going to take us to the issues tab, so on and so forth. Here, it going to add the filter for assignee. So assignee is here is where it's supposed to have patched in the name which I had issued, which was Abhishek, and selected here Abhishek as Abhishek. Right now, the front end part isn't working, but I just wanted to show you why or how this LLM has been envisioned to set up. Now I will take you to the backend which I have written and show you what it takes and how it is currently working. So the backend is supposed to get an input like the user search term, like how much time did I just spend on Udan, and so on and so forth, and a list of all the recordings which are available. This is all, by the way, this has all been written in Python. It's deployed on AWS Lambda, and it uses a Bedrock LLM implementation. Let me just do a quick run for you to show you. This is all I do a test drive using Postman. So suppose the user query was show me issues assigned to Abhishek, and these are the list of all the queries available. Once we send this to the LLM backend, I'll show you the deployment in a minute on AWS Lambda, but just let me run it to show you that the backend is working. The front end is the one which is currently broken. So it performs 3-4 LLM requests inside of it, which is why it's a little slow. But anyway, see, so show me issues assigned to Abhishek. It has found out that the closest recording is show me issues for Yuresh, which looks like exactly the same. In terms of input values, it has correctly assigned that the drop-down user, the input value has got to be 99, which is the one for which matches Abhishek. And if the front end would have interpreted it correctly, it would have run this recording, and instead of Yuresh, it would have selected Abhishek. Uh, the rest of the things are internal fields. So this is how it's actually working. Let's do a deeper dive into how exactly it is working. So as I was saying, this is all deployed on an AWS Lambda function. I'll also give you a link to the GitHub, which contains the actual code, which takes the user search term and maps it the correct recording and patches in the correct entities. So let's just take a quick look here. There's this wrapper function called call LLM. In between, the client said that they don't want to use Bedrock, they want to directly make a call to Anthropic, so that functionality is implemented. But let's come to the interesting part, which is get input values with bounding box. So in a lot of cases, we need a bounding box. The LLM cannot directly patch in the right values. So let's take a look at this get input values with bounding box. Essentially, what it does is that from the front end, we get a HTML dump of the list which we are trying to map. For example, if in the case of usernames, it could be Abhishek99 and so on and so forth, followed by the user IDs. And the job of this function is to map each of these inputs to the right value from the bounding box. How does it do it? It parses the HTML, so on and so forth, and then there's this prompt. Yeah, this is the heart of the function, which has this prompt: given the following user query and the following input names with their possible values, please search for the most appropriate value text for each input name based on the user query, blah blah blah. And then there's some metadata to help the LLM. After this function is run, the LLM actually does that mapping, like this mapping. That drop down user has to be mapped to 99. This is all deployed on GitHub. I'll give you a link to this GitHub as well. What is interesting is that we have also deployed a CI/CD pipeline here, which means that anytime I perform this check-in from here, uh, it directly goes to GitHub, and from GitHub it is directly deployed to AWS Lambda itself. So let's see if we can perform a simple operation here and see it like within a minute. It will reflect uh, on the server itself. One of the things which we keep doing is this, like when we want to speed things up, we use a smaller version of the LLM. So so here the non-trivial LLM and there's a trivial LLM where we're using Haiku and Sonnet. If for whatever reason we want to use Haiku for both, we can set the non-trivial also to Haiku, and let's see that working. Uh, 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 Non-trivial will also start using Haiku now. That'll speed everything up significantly, although the the accuracy might go down a bit. Before I push this to production, let me show you that where all is going to make a change. So here, this is the Lambda function. This is in GitHub. As you can see right now, it's the non-trivial ID is set to Sonnet. As soon as we perform this check-in, um, let me just go ahead and perform this check-in. Yeah, so this is the only function we have changed, lambda function.py. So I'm going to stage this, and then let me also commit it. Let's say that test non-trivial set to Haiku as the commit, and then and say save all and commit changes. Okay, so now hopefully this would have gotten changed here. Yes. No, it has not yet reached here. It get stuck. Where is the push? Push. Yes. Test commit. Yes, so we have been able to push it, and here we can see that the non-trivial has now become Cloud 3.5 Haiku as well. And if we go to actions, we will see that this change, yes, this change now has triggered a workflow run, which would have sent this, okay, yes, this would have sent the code directly to AWS. Let's just see if it's here. Let's go to the code here. Code. Okay. So it has not yet reached here. Open it again. Yes, has been updated. Yes, accept. And as you can see, this code has reached this place. Non-trivial sonnet has been commented out, and non-trivial haiku is uncommented. And this should auto deploy as well. We should ideally have to deploy it. It should auto deploy it. In case we just hit deploy from here. Oh, no change to deploy. So this has been deployed. Now what is interesting is now when we run it, it should run a lot faster because the model has been updated from Sonnet to Haiku. Although the accuracy might be lower. Yes, so it has run. This time it took 15.61 seconds. Last time I think it had taken around 20 seconds. So one of the calls, the non-trivial calls, has been replaced with Haiku. So I'll leave you with a link to the GitHub. Feel free to go through the code. I've coded it mostly in Cursor uh, using Cloud 3.5 Sonnet as a helper here. And yeah, that's it. Thank you.